Hello, my name is Pritam. I live in West Bengal. I am currently pursuing BTech in Chemical Engineering at NIT Durgapur. For the last 6 weeks, I have been working in the Nanotechnology Laboratory under the supervision of Professor Venugopal Shantanam. Our main goal was to make a new printing system for printing the chemicals with high loading efficiency with a 2D CNC plotter using arduino-controlled stepper motor. Initially, we were introduced to the printing system that was already available to print the chemicals for making the silver nanoparticles and silver nanowires. You need to print the silver nitrate and the potassium halide using the inkjet printer, then expose it under halogen light, and then develop it with the help of the developer solution. When we print the silver nitrate with potassium chloride, we get silver nanoparticles, and when we print the silver nitrate with potassium bromide, we get silver nanowires. But this method of printing has its own disadvantages. Firstly, the loading efficiency is very low. Secondly, there is inconsistency in the deposition amount while using different printer heads. Hence, an alternative method is required. One method is to use a 2D CNC plotter with a brush. With this method, results are consistent and loading efficiency is increased. But the main problem with this method of printing is that the brush will be in contact with the printing paper and the material pickup will be there. For this, we came up with the idea of the contactless printing with that same 2D CNC plotter using a 31 gauge syringe. Its advantage over the brush is that it's a contactless method, hence no material pickup will be there. With the help of a stepper motor, a linear and uniform push is given to the big syringe that is connected to a small syringe with a 1 foot length plastic pipe. At different speed, different type of liquid flow through the syringe is observed. But the main challenge with this method is to be able to stop the liquid flow through the syringe as soon as the printer head of the 2D CNC plotter goes up. For this, we had tried different methods. Firstly, we tried to control the stepper motor with a different microcontroller and cut the power to the stepper motor with a relay module as soon as the printer head goes up. But this method didn't work as the microcontroller stopped executing the G code as soon as it happened. Then we moved on to controlling the stepper motor as per the signal received via the MPU 6050 accelerometer sensor. But this method also didn't work as its response time was not fast enough to accommodate for all the future actions that the stepper motor needs to take based on the printer head position. Then we finally came up with our final solution, that is to control the stepper motor using the Arduino with the help of a A-Phone 988 driver. For this method, we have used a custom-made sensor that is basically a pull-down resistor switch. When the printer head goes down, then the circuit is connected and Arduino reads a high signal. When the circuit is not connected, Arduino reads a low signal. This method is very fast as the switch itself works as a sensor here. After the whole setup was done, it looked like this. As you can see that the small syringe is connected to the 2D CNC plotter and the Arduino is connected to the stepper motor. With this setup done, we moved on to the analysis part. There we have analyzed several important factors and parameters like the relation of number of drops and the amount of liquid dropped with different speed of the motor at RPM. We have also realized that liquid drop was majorly dependent upon the inertial force and the surface tension of the liquid. So we have measured and analyzed the Weber number and found it to be very small at lower motor speed. Here you can see that the plot between the speed of the motor and the number of drops per minute is not linear, although error bar is very negligible at lower speed. While analyzing the liquid flow pattern, we have discovered one interesting phenomena. We found that the number of drops at specific motor speed were not uniform with time and it had an oscillatory nature. Although further analysis is required for this, but as of now our guess is that it is happening for using plastic pipe and due to its flexible nature. This is what we were able to do so far, but I would like to mention some scopes for improvements and some challenges that we have faced. Firstly, the drop size is bigger than what is desired. Secondly, you can see that the liquid is not immediately absorbed on the paper. Although further analysis is required on this part, our suggestion is to use a 34 gauge syringe needle instead of the 31 gauge syringe needle that we are currently using. That should make the drop size smaller. And for the absorption problem, we have added 30% isopropyl alcohol to the liquid that we were printing, and that seemed to solve the absorption issue, as you can see in the image. I would like to end my presentation here. Thank you for your kind attention.